Hi, welcome to my channel Cloud with Girish. In this video, I'm going to show you how to build a serverless generative AI solution to Inpaint images using Amazon Bedrock API, Lambda, REST API, and Amazon Titan model. Amazon Bedrock is fully managed service that offers choice of many foundation models like Anthropic Cloud, AI-21, Jurassic 2, Stability AI, Amazon Titan, and others. I will use Amazon Titan image generator model and will invoke it via Amazon Bedrock API. Let's understand what an image inpainting is. Per Wikipedia, inpainting is a conservation process where damaged, deteriorated, or missing part of an artwork are filled to present a complete image. This process is commonly used in image restoration. In this example of image inpainting via generative AI, I will inpaint the image by removing the object from the image. Stability AI image and Titan image generators are two popular language models for generative AI image generation. Titan image generator is the image model by Amazon. Amazon Bedrock service provides integration with both the image model. However, I am going to use Amazon Titan for this workshop. Keep in consideration that each model has its own set of parameters, so when invoking the model via Bedrock, pay attention to the parameter required for the prompt. Let's look at our business use case. We need to update Inpaint custom image based on text prompt. Custom image can be used for article or product designs. It's experimental in early phases, so multiple images with some variation required. An automated solution is required to inpaint the sample images. An automated solution will provide a repeatable way to inpaint sample images. Invoke the generative AI image solution via API and store the generated image in S3 bucket. It will increase in productivity as team members usually work on creating sample images can focus on other tasks. I will be creating the Lambda function via infrastructure as code approach using AWS Serverless application framework and CloudFormation. However, you can create the Lambda function using the AWS console as well. Let's look at our architecture design. We have the user that's invoking a REST API via API gateway and passing the image prompt. The image prompt is getting passed to a Lambda function written in Python and Boto 3. This Lambda function is invoking the Bedrock API, which is using underneath a foundation model by Amazon Image Generator. It will return the image in the response, and also the image will be uploaded to the S3 bucket. Of course, the CloudWatch is there to log all the events. For the prereqs, just the familiarity with AWS console, your imagination or image requirement for your product or business, knowledge of Python Boto 3, some knowledge of AWS Lambda, and basic familiarity with generative AI and foundation model concept. Let's get started. We will review the Bedrock service, we'll review the foundation model, we'll request model access, we'll also review the playground provided by Amazon, we'll review some key terms like quality, number of images, CFG scale, height, width, feet. We'll review the SEM template and the Lambda function. We'll also review the build function, invoke function, and deploy function using AWS SEM. We're going to validate the Gen AI model response using a prompt. I'm going to use Postman to invoke the API, and then we'll review the response images. We'll also review CloudWatch log and also some Bedrock service pricing. Like I stated earlier, I'll be creating the Lambda function via infrastructure as code approach using AWS Serverless application framework and CloudFormation. However, the same function can also be created using the AWS console. Let's review the Bedrock service. Amazon Bedrock is fully managed service that offers choices of many foundation models like Anthropic Cloud, AI-21, Jurassic 2, Stability AI, Titan, and others. Since Bedrock is another serverless offering from Amazon, it allows integrating with popular foundation models and also allow to privately customize foundation models with your own data using the AWS tools without having to manage any infrastructure. Let's review these foundation models. So we got Anthropic, we got AI 21 Labs, we have Amazon models, we got Cohere, Meta, there is a new addition, Mistral AI, and then also there is another imaging foundation model, Stability AI. For this workshop, I'll be using Amazon Titan image generator model. Before model can be used, you need to request the access to the model. So I'm gonna go to manage model and request access for Titan image generator, and I will request the access. For Amazon model, typically it takes few minutes to get the access. Once I have the access, I can also use AWS provided playground via console to generate the image. However, I will not be using the playground, rather I will use Bedrock API to provide prompt and then get the response, which will be my updated Inpainted image. Let's review a few key terms. These key terms are used when defining image generation config. So quality, we have an option to select standard versus premium quality for the generated image. Number of image is a value of 1 through 5. Default value is 1. There is also another parameter CFG scale is a value of 1.1 through 10.0. Default value is 8.0. A lower value indicate more randomness in image generation. And then there are height and width parameter with default value of 1024. Seed, that's another parameter, value of 0. Default value is 0. This value control how image is reproduced. Use the same seed value to generate same image with each run. Next, let's review our AWS SAM template. This is the template where we define the resources. As you will see, I have two key resources defined in my AWS SAM template. One is my image Inpainter function, and this is the function that is invoking the Bedrock API. The handler is image painter. Its runtime is Python 3.12. My timeout is 120 seconds, and then memory size is 128. I'm also defining an environment variable, which basically I'm using to pass the model ID at runtime, and also my S3 bucket. The another resource defined here is the API, the REST API, and that is the API that's integrated with the Lambda function. Let's look at our Lambda function code here. So we got our handler. There are some standard best practices logger and try catch block. I'm also checking that if my REST API is getting invoked using the post method. If it is not a post method, then I'm providing the message back without doing any further processing. Then I'm building my prompt body, and this is where you will see that my image generation config parameters, right? Number of images, height, weight, CFG scale, etc. that I'm defining here. And then I'm invoking the Bedrock API, which is gonna generate the inpainted image. To build this function, I'm using the AWS SAM. The command is as simple as just typing SAM build once your environment is configured. And once build is succeeded, I can actually invoke the function locally without deploying the function to the AWS cloud. So for that, I'm using a SAM local invoke command, and I'm invoking the function. Once my function is validated, I can deploy the function using SAM deploy command. I will validate the generative AI model response using a prompt. So I have my API endpoint since I'm deploying the function, and I can pass in the body my prompt. So here I'm passing the source image and also the prompt. So I'm using Postman to pass the prompt and the source image name to the API, and is passing it to Lambda and Bedrock. So in this example, black cat will be removed from the image. So let's see, once API is invoked, this is my source image that I passed, and with the prompt naming that black cat. And if you see in my Inpainter image, the black cat has been removed. So this is the response, the result of my API call. If you review the CloudWatch log, you will see that there is a confirmation. My Lambda function is getting invoked, and any logging information that I have coded for, that will show up in the CloudWatch log. You will also see that it has a confirmation that image has been uploaded to target bucket, and that is the image that has been generated. Some note about Bedrock service pricing. So it's based on your image resolution, your quality, different prices for standard quality versus premium quality. So something to keep in consideration. With this workshop is serverless generative AI solution for custom image in Painter using AWS Bedrock, Lambda, and API gateway has been successfully completed. Python Boto 3 were used to invoke the Bedrock API with Amazon Titan image generator model. As GenAI solutions continue to evolve, they are set to reshape traditional workflow and drive tangible benefit across industries. This workshop serves as a compelling example of the transformative power of AI technology in addressing real-world challenges and unlocking new opportunities for innovation. Hope you enjoyed this tutorial. I'm working on some other interesting content on various AWS topics. These will be posted soon. Please don't forget to like and subscribe. Thanks for watching.